Welcome, everybody. Let's get ready for a new Midnight session where we keep learning about the Midnight ecosystem. We go to technical deep dives and learn how to write smart contracts. And then we go through some questions and answers. So let's get started. Related to the ecosystem, now we're going to go through some new releases in the catalog, which we're going to talk about Lace, right? Which is one of the big partners in the Midnight ecosystem. So we are going to go to Google Chrome, and we're going to take a look at what Lace is building and how it's supporting the Cardano and the Midnight ecosystem, actually. So if we go here to Google Chrome, we can see that in Lace, we actually have two wallets available. One that it's already available for the Cardano ecosystem, where we can see our tokens, NFTs, activities. We can stake the tokens in multiple SPOs. We're gonna be able to do some governance as well, voting. So far, they're using this external tool that is called GovTools, but in the future, they're gonna add some native functionalities regarding the governance processes. And then you can actually go through some dApps that were registered in their platform, and you can just use these dApps within. Also, this is a new feature not available now for me, but it's been rolled out to other beta users, which is DeFi Bitcoin, which is huge news when we're going to be able to use Bitcoin natively and operate and use some Cardano dApps. So that's gonna be huge for the Midnight Cardano and Bitcoin ecosystem. And they also mentioned that they want to integrate other blockchains as well. So this is gonna be a new release that we're gonna see in the future about Bitcoin DeFi. And then in the future, Lace, they're gonna integrate Midnight. But so far, we have to download a specific wallet that just integrates Midnight functionalities. For this, we have this Midnight Lace. So far, we can just see tokens, and we can connect to external services. If we go to settings, I can see my password. And then we can see here that we can connect to different networks. So far, we have testnet and deployed. We have a node address. We have a proof server. Midnight, it's all related to zero knowledge. So this proof server is the one that creates that proof. An indexer. And also, you're going to be able to connect to dApps. So this is what Lace is building for the ecosystem. And it's going to be one of the many wallets supported. So on the next sessions, we're going to go through other wallets that are also integrating within the Midnight ecosystem. Okay, so regarding blocks, the latest one, which is really nice, a good opportunity for anybody that is building on Midnight, we have a partnership with the Outlier Ventures and Midnight. What this partnership is about? These guys, they're offering a base camp. So it's kind of a accelerator. So if you have a project that fits within what they're looking for, you might be you're gonna be able to apply and be selected and go through this acceleration process. So let's take a look at the scope of this partnership. So we can see here that they are focusing on PETs, PETs, which is private enhancing technology. I kind of divide all these technologies, privacy technologies, in three. We have zero knowledge, we have NPCs, and we also have trusted execution environments. So they are actually interested in two technologies. One, it's the zero knowledge, and the other one, it's the here they say zero knowledge, and the other is the trusted execution environment. So if your project fits within this data scope, you are going to be able to apply. Okay, what is the scope? What kind of projects besides been developing something regarding to privacy, you need to have. You probably could be related to here they are mentioning what they are offering, right? So they are offering an initial seed investment, and in the future, Midnight themselves, they might support you with extra funding. You're gonna have technical mentorship from the Midnight core teams, zero knowledge cryptographers, and the Outlier Ventures in-house token and go-to-market technical and product team, which is huge. Compliance, right? So they are gonna go through all these processes: GDPR, HIPAA, CCPA, and go-to-market support. These guys are specialists on how to go to market and the different marketing strategies. And what type of projects they're focusing? Everything related to identity, infrastructure, open finance, and privacy middleware. So at the end, people are going to be able to apply. If they are selected, they're going to go through a 3 months boot camp. And they are providing here the links, so anybody's free to apply. And this is a huge opportunity. Perfect. Now regarding the education. So Midnight, they are giving these academy tutorials. So they're going to be huge. So we're going to go through the process step by step. And in this session, we're going to take a look at the first module, specifically the history and evolution of blockchains, right? So what they are mentioning here, that blockchain went through a process that it evolved from blockchains of kind of the first generation blockchains. Then we went to the second generation blockchains, then third generation blockchains, and now fourth generation blockchains. So we can think of the first generation as Bitcoin, which give us decentralization and peer-to-peer communications and transfer of value. Then the second generation blockchain started to use smart contracts, so which is programmability. The third generation, which we can think of Cardano, we actually solve some critical issues, which is energy efficiency, scalability, and interoperability. And now we're in the fourth generation, which is Midnight, that solves offers two huge features that are necessary to actually create applications for businesses, which is privacy and regulation friendly. So so that's the first part that they mentioned about the academy. In the next session, we're going to go through some cryptographic concepts for us to learn how to build on Midnight. Okay, and now regarding to the hackathon, we have an ongoing hackathon regarding to tooling. It is open for anybody that wants to create tools for smart contracts, developer experience, SPOs. So any tooling that lower the barriers for entry for new developers and ecosystem contributors. Within Mesh, we are actually doing tooling. That's something that we do, and what we are opening our doors for new collaborators that want to start building on top of what we are doing. And we have 3 projects, and one of them is the NFT ecosystem. So we're building education, something that we're doing now, tooling, and hackathons. So John Santi is one of the members in charge of one of these projects, and he's doing the dev collabs and education space. So anybody who wants to collaborate, the Discord is open. So if you go to Discord, we have now created this channel within the Mesh organization Discord, which is called Ask Midnight. Here, people can create questions, and John have created this kind of question that integrates everything that he's doing about this project, which is dev collabs and education NFT. And in here, he has shared some nice documents on the ideation process and some pictures. So yeah, anybody is free to join, or create a question here and we might give support. Excellent. So now let's start learning something about more technical necessary to write smart contracts. In the last session, we learned how to build our first smart contract and how to compile it. Now we're going to understand how secrets, how the witnesses are written, how we declare some types, and some configurations and some macro structures of how Midnight works. So let's go to the code. So here, the last session, we learned how to build this and how to get these outputs. Now we're gonna go through the witness file. Here we declare the structure of our private information and we declare the oracle. In this case, for the contract that we are learning, which is the counter contract, we don't interact with a private information. Nevertheless, we still have to declare one. The most basic one, it's this kind of private information, which is I'm declaring the type as a counter private state, and it's just an object that it's a number. So this is the most simplest declaration of a private information. And then I create a function to create a type, a variable that has this type, counter private state. Since we don't have since the contract doesn't interact with a private information, we just need to declare an empty object as a witness. In future contracts, we're going to learn how to structure this witness, which is the oracle. What this oracle does, it's our bridge on how the contract is going to integrate and use the private information stored in your computer or somewhere else. Okay, now that we have declared the private information, we are done with this first file, which is the contract file. Now we are going to the counter CLI. In this file, this is where we start declaring the types and configurations and some code to interact with different providers. We're going to learn all these words that I just mentioned. So regarding to types, we have to declare these basic types. One declares the type of our circuits. So we're using some types provided by the Midnight.js or Midnight SDK. In this case, it's from the Midnight.js types. So we're using this type and we are passing the contract class that we got by compiling our compact code before. And then we're passing the type of our private information that we just declared. Then we're defining how it's gonna be structured, our private information. This is something that changed from previous versions. Now we are allowed to our private information, we can create it in an object and have different types. So if your smart contract needs to have different types and different points to entry, now you're going to be able to do that. In this case, we're just declaring a boilerplate private information since we don't need any. Then we have to declare the providers as well. This type we are getting from the Midnight.js packages, and we are passing the counter circuits and the counter private state. We are going to learn now what is these providers about. And then we are declaring the contract. Again, we obtain this type from the compilation of the compact contract and the type of the contracts that are being deployed or created. So with these types, we have all the types necessary to actually write code. So we have these types plus the types created on the first file, in the contract file, after compilation, where we got this index DCTS. So this is all the types. Right now, it's a lot of types. For new developers learning how to write smart contracts, it looks like a lot of types, but don't worry, it's just types that we're gonna need to actually write code. Excellent. Now, After having the types, and we need to declare some configurations. Configurations about what? Where are hosted our instances, right? So before going to explaining this object, we're gonna explain what is these providers about. For this, we have created a nice graph that actually explains how Midnight architecture works in a really macro way. So I mentioned providers, right? So what is a provider? We have 6 providers in Midnight for writing code. We actually can create custom providers, but the providers embedded within the libraries of Midnight are these 6. One, it's the indexer. The other one, it's the node. The third one is the proof server. Another one, it's the wallet. The other one, it's the oracle that I just mentioned, where it's kind of the bridge how we interact with our private information. And the other one, it's our cryptographic material, also created when we compile our code. So we have to declare all these providers. And this is something nice about Midnight. When you write code, you are provided not only with code, the logic, but actually with all the instances. So you're not gonna need to create your own instances to actually have an end-to-end application. You're gonna just write code and use the existing infrastructure to be able to create a end-to-end application. So now we have to tell our code where this instance is hosted, where this is hosted, where this is hosted, all this, where it's going to be able to, our code to find this code, right? And instances. So this is where we are declaring this, the config file. So in this case, we have 2 types, two kind of, let's call it, 2 ways of configuration of our code. We can run it as a standalone configuration, or we can write it as a tested remote configuration. What is the difference? In the standalone, you actually host all these instances. And the testnet, you actually use some instances hosted in the cloud and others in your machine. So let's take a look. In the standalone configuration, we're saying here, where are we going to find our cryptographic material? In this case, we're going to, this is the log directory. Here, the indexer. Where are we going to find our indexer? So we're telling the code, okay, this is where is going to be located our instances. How are we going to run it? Using Docker, and we have the Docker containers. Where we are declaring that Docker, we have this other file under the YAML, where, for example, when a standalone, you choose to run something in a standalone, you're going to use this YAML, a standalone YAML, and you're telling the code here that my indexer is going to use this image. So using Docker, you just download this image and you run it on your computer, and now you have that instance. For the node, the same thing. We are going to host it under this IP address and port, and we're going to download the instance to run it with Docker. Again, we see the YAML file. We're going to see that we have a node package that is going to use this image. So in this way, we are downloading the instances, hosting them in our computer, and telling the code where to find that instance. In the case of tested remote, we can see here for the proof server, we are going to host it because this is something that developers have to design on your applications, where you want to host the proof server. It can be on your computer, or it could be in the cloud, actually. In this case, we're hosting that on our computer. And for the indexer and the node, you see that we're using some links. So actually, those instances are being hosted by somebody else. In this case, the Midnight team are hosting those instances, and we can use them. And these instances are actually connected with the Midnight blockchain. right? So different nodes get together. So it's kind of simulating what is the real use of the Midnight blockchain. So my recommendation when you're creating smart contracts is to start with a standalone configuration and then use testnet remote. Okay, perfect. Having these configurations and the index, the next step it's actually to test. So the testing, that's something that we're gonna go through the next session, but I'm gonna just give an overview what is this testing about. Testing, it's all regarding, okay, I'm writing my code. How do I make sure that it's actually working? So I divide it in 3 phases. The first phase, it's the logic phase. I want to make sure my logic actually makes sense. So for that, you don't need to use instances. You just need to make sure your logic works. So in the first folder, we have a folder called test. So in this we have a framework for testing our smart contracts. We are not using any instances. It's just logic. We're gonna go through that in the next session. On the second phase, we actually use the instances. So we here have as well some tests that we are actually going to test our code using the different instances. We can do it automatically using Docker and those YAML files that I just showed you before, or you can actually create your CLI, which is kind of a TUI, a text-based interface, right? So here, the user can go through a process where you ask him certain questions, and you can go through the process depending on what the user wants to do, right? So yeah. So this the logic. The second, a standalone, a CLI as well, and the third one, it will be using the actual Midnight infrastructure, the clouds, those links that I just mentioned that are hosted by Midnight. And once those 3 phases passes, you can be sure that your logic is okay. Your circuits are created to fit the blockchain, the Midnight block sizes, and only then you go through the UI part. So actually create a user interface. So yeah, so this is the one of the steps. So we're starting just with the contra example, which is really simple. But at the end of this process, you're gonna see that just by understanding this contra example, you're gonna have the tool necessary to create any contracts at all. Because at the end, the instances for the contra example are learned, and you know how to run those instances, and then it's just writing logic. Okay, so this is about the technical deep dive. Now I'm gonna open to some questions and answers or discussions. So I'm opening the microphones for everybody here. Okay, mics are open. If anybody has any question, feel free to just ask. Hey, Leif.
Hey, thanks. Good presentation so far. Thank you. So I was reading through the Midnight documentation a couple weeks ago, and I had a hard time understanding how, like, the where validator nodes and like how the Midnight blockchain is actually structured. Like that's kind of what I'm a little confused about. Like I kind of hear it's interoperable with other chains. I also heard somewhere somebody told me it's using Cardano as like a base layer for decentralized security. Like they're using the validators on Cardano for something. But yeah, is it like its own blockchain or what's going on there?
Okay, yeah, it's actually the Midnight ecosystem. It's really complex. It's solving a lot of stuff that a lot of things that you just heard are kind of work in progress, right? But like in a really macro way, the way it works is like this. Midnight, it can act as an L1 or can be an L2, depending on what you need, right? If Midnight offers the features for your application, all the features for your application, you can use it as an L1 and that's it. If another blockchain offers 90% of the features that you want and you just need that privacy part, you can actually use Midnight as an API, right? You just use that privacy thing, and then the 90% you use whatever other technology that you want to develop. So this is kind of the first concept. So it could be either L1 or L2, depending on your needs. Now, the architecture of Midnight for the application stack, it kind of works this way, right? We have an indexer, we have a node, we have a proof server that connects to a wallet, and the developer writes this code and this code. With Compact Compiler, you compile this code to JavaScript, and here you write your logic, and then you just use all these instances provided by the Midnight ecosystem to actually do all the integration. Now, how it connects to other blockchains, right? What happens for a blockchain, right? You need nodes, right? Nodes. And for that you need a consensus mechanism, right? For consensus, there are different types, and this is a whole concept behind of that. But the way Midnight wants to use consensus, it's kind of have the benefits of something more specific like BFT, but it still have the security that Cardano offers. So what Midnight is going to be able to do, it's like using the SPOs of Cardano, and Ouroboros is actually going to select who is going to be the node that actually creates a block, right? So security, it's governed by Cardano. And the nodes
on the L1 of Midnight.
Yeah, here Cardano, it's L1, right? And here Midnight, it's let's call it a blockchain, depending on how you want to use it, L1 or L2. Let's say here that's an L1, right? So the Midnight, it's working as an L1. If you, a developer, use Midnight as an L1, or you're using your application with another blockchain that solves 90% of your problems, and within this blockchain, then you call as an API some features of Midnight, you are actually using Midnight as an L2, right? Everything is going to depend. And why this confusion, it's kind of hard to understand, because before, for an L2, you have like kind of roll-ups, right? Now, with CK, everything boils down to a proof. So how this communication, this is a feature not available yet, right? That's why maybe people are confused, but kind of the goal is actually to do that, right? So you just send a proof to the system. The system just needs to check the proof, and if that passes, that other system feels okay to say, okay, I believe on what you're saying. So he performs some stuff here, and then he responds, right? So yeah, that's kind of Midnight wants to offer these privacy features that can be as an L1, L2, but it's gonna be at the consensus level. It's gonna be secured by Cardano. In the future, with Minitor, actually this security at the consensus level can be provided by other blockchains. Could be Bitcoin, it could be XRP, right? Leif, I cannot hear you.
Oh, sorry, I don't want to take up all the time. I have follow-up questions, but if somebody else wanted to ask, I don't want to overstep.
Okay, let's see if somebody else have a question. In case nobody has any question, you can go ahead, Leif. Yeah, Tosi.
Hi. Actually, I have I want to deploy their contract for counter example, but the main problem is um, counter example is very easy. So for bulletin board, it's should I write all the codes whatever is written in cli.ts file for counter?
Okay, so yeah, the counter example actually, yeah, as you mentioned, it's easy. It's still really powerful to understand how everything gets connected. If you can, we we in Mesh, we're gonna the Midnight team, they have just released the counter, right? In the future, they're gonna update the bulletin board with the updated libraries, and we in Mesh are also gonna upgrade all the examples that we did before. But if you just want to kind of have an understanding how everything gets connected from for a more complex example, all the way to how to create the UI, you can go to the Mesh repository. We're going to pin here. You can go to the Mesh repository under Midnight. Let's find Midnight. This is the repo that we are hosting all our libraries and examples. So you can go to examples, and this is where we want to write all our code. So you can take a look at this file as inspiration. Some of these are empty still, but one that it's we actually have all our code, and something that we participated in the one of the previous hackathons. It's this Midnight auction token. So here we have a contract for auction, a contract for tokens, and actually how to integrate everything on a UI. This repo works in a standalone using the specific versioning at that time. So what we need to do is update that library for the current versions, right? But you can take a look at this example and have a third understanding of how to implement and how to write code in Midnight end to end.
Okay. Mainly the problem is that I try to do first of all for counter example I try to understand the codes. So for deployment part, some I cannot understand some part. The CLI.ts that's the correct one. And
Okay.
mm,
Okay. Okay. Regarding deployment, don't worry. We're gonna take a look that in if it's not the next session, the next after that, and where that deployment comes, we have a file here in the API, and you can see that we have a function called let's find it. It's called deploy. We have deploy and join contract. So the Midnight SDK offers us with these abstracted functions that are called find deploy contract and deploy contract. So we just need to declare our providers, right? We're gonna learn how to do that. I just explained what are these providers about, and then we pass the instances of our contract and the instances of the private. And now we have this deploy contract API that offers kind of a really abstract API that we can call methods on it. What kind of methods? Calling our circuits. So we don't have to understand all these cryptographic workflow behind. We just call that method and actually execute the execution of those circuits in our smart contracts. But we're gonna take a look at that on the next session, on the next after that, in case you have any questions about that.
okay, thank you so much. It means a lot. I want to know that there is in the document midnight.js SDK. So can I use all these for wallet connection or deploy a contract? Can I use all of this?
Yeah. The dogs, they are really powerful. They just need to upgrade the. If you take a look at the build section, for example, let's say
It's in
midnight.js
reference
API.
document.
You can see that
Right.
it's in version 1.0. The latest one, it's not 1.0, right? So this is they have to upgrade still the documentation. So yeah, you Atosi are going really fast. We're gonna catch up with the Midnight team that are actually gonna update that documentation. But yeah, it should be 80% okay. Maybe 20% things that are not updated, and you want to go through the code itself. If you download the libraries and download those functions, you can actually see what is the TypeScript structure of that function, and you can have an understanding what kind of arguments you have to pass to that function. But yeah, in docs, we're gonna have to wait for these docs to be updated. And also, it was released before. For some reason, I've seen that they have took it away. They have integrated Kappa AI for the documentation. So you're gonna be able to talk with that AI that it's trained on this documentation, and actually it's not gonna be able yet to write code, right? But he's gonna know anything about the concepts of Midnight and some things about coding, right? So we're gonna in this session we're gonna use a lot of these AI to actually answer questions, or if we have any doubts, we can go through that process.
Okay. And one more last question. In Cardano, we use for any transaction we use Cardano CLI. So, is there anything in Midnight like that?
Yeah, well, that's a really nice question. What happens in Cardano? It's Midnight offers tools that are more opinionated, so you have less flexibility. But actually, when you're writing contracts with Midnight SDK, you are actually kind of building an application that it's ready for end users to use, with indexers, proof server, everything, right? So what they've done is kind of create this abstraction, so developers, they don't have to go through this wingle process in the middle, right? In the future, what they want to do is actually make it less opinionated, and we're gonna have more flexibility to actually write code, and that's something that Mesh actually wants to do. What happened in Cardano, it started really low code, right? So we started with something with serialization tools, right? And from there, people started building tooling for writing transactions, indexers, and so on, right? So so far in Midnight, you don't have you have transaction builders, but fit of what Midnight.js allows you to do. You cannot just write whatever transaction you want. Right now, transactions are based on transferring tokens using the wallet API. And for the contract specifically, you write your circuits using Compact. And then with the Midnight SDK, they're just gonna let you write that circuit, and that's it. You cannot just have flexibility to write whatever transaction you want. So far. In the future, they're gonna give tools for that.
Okay. Thank you so much. Thank you.
Thank you, Tosi. Leif, you can ask this other question.
Yeah, thanks. So you're mentioning the word circuit as like a concept, like an abstract concept. I'm not on board. Sorry, I'm not up to speed. What does a circuit mean in the context of that?
Okay, so so what happened? It's that in Midnight we have a two different states. We have a private state. Sorry, it's not working. We have a private state and a public state, right? So you need to talk with the public state using your private state, and for that you use zero knowledge. So how do you?
Yeah. Oh, I'm sorry. Just because I'm not actually big into cryptography. I have a high level knowledge of like zero knowledge proofs, right? But for the data that's actually being stored on chain, is it just like encrypted data that you can decrypt with a proof? Is that what's going on? Or what
Yeah.
does zero knowledge data mean? Like,
Okay. Yeah.
sorry.
No, and that's okay, Leif. I mean, the zero knowledge stuff, it's really complex. And actually, we're using zero knowledge at different levels and a different level of the stack of Midnight. So yeah, it's understandable all your doubts. And thank you for asking that question. So anybody who's listening is going to learn. So what happened here is that the zero knowledge, right? Actually, you create it on your computer and you send it to the node. And the node processes that proof. And with that proof, you're telling the node, for example, I'm older than 18, right? I have X amount of Edda in my wallet, but you don't have to show him that data. You are just proving a assertion to the node. So that zero knowledge, it's actually doing that part. So the node processes that zero knowledge and let you do things. For example, I want to increment that counter from 0 to 1 only if you have 10 ADA in your wallet. But you don't want to show your wallet to the node. You just want to make sure that he believes that you have 10 ADA in your wallet. So this is zero knowledge.
Can the node see that the counter was incremented, or can the node not see?
Yeah, so that's where the state in the private and state in the public. You decide what you want to make it available in the public state, and you decide what you want to make to leave it in the private state. So that depends on your decisions as developers building on Midnight.
So, and then when you define these states, right, these private states, and you're saying here witness, I assume witness is like an array of public verification key hashes that can read the private data. Is that what witnesses are? Or
no, witness, it's whatever data structure you want to implement on your computer. It doesn't matter. You just write information. It could be your own database. Private information could be your own database that you use that private information to use it on your computation that runs off-chain. And the circuits, it's what actually create that proof. So you don't need to understand, you don't need to be a specialist of cryptography and learn how to write this zero knowledge. You just write circuits. And what is circuits? It's functions. It's just a function. So we just call it circuit because it creates those zero knowledge, right? But it's functions. It just do things, right, for us.
Okay, cool. So circuits, just the functions
functions that you write to use your private information and to be able to communicate from the private side to the public side. So this is a circuit. A function that connects these two worlds.
Oh, so okay. So this, I guess, maybe this is just too basic of a question. Maybe I'm going to annoy you with this one. But so in my mental model of this, the point of Midnight was to store private information on chain and to allow, because it's just my assumption. I'm not saying this is correct like at all, right? It's probably wrong, very wrong. But then to allow these public keys to read that data. That's what I assumed it was, or mutate that data. But what you're saying here is the actual private data is being stored in like centralized databases, and mutations of that data are like the proofs of the mutations of the data are what's being sent to the public, getting added to the block.
No, the private state could be on a centralized database, or it could be on your computer, could be whatever place. I mean, the private information is just a private, right? And what the zero knowledge it's about is to prove something that something was computed with your private information. For example, you have your passport, right? You have a lot of information in it, where you live and your age and so many information. but you just want to show me that you are from a specific country, nothing else. But for me to believe what you're saying, you have to show me your passport to see, okay, I want to see your passport, but I'm learning other information within your passport. With your knowledge, you're going to be able to prove that an assertion that corresponds to some private information, that it's your passport information, and you just create that proof based on those private information, and you just send me that proof, and I'm going to be able to believe you.
Okay. That makes sense to me. Okay. So if I wanted to say, like I'm in possession of this token on a blockchain or whatever, you spin up a proof server, you have all that infra on your side, and actually it might even be public information or private information, it doesn't matter. You write a public assertion that can be seen by both the end application and on your side, and then you run that assertion, your system creates a proof, and you send that proof over to the application.
Exactly. And that's why we say that Midnight is regulation friendly, because think about a public blockchain, like for example, Cardano. We can do some operations on chain, but you don't want to tell anybody who you are and on what you're doing, right? So everything it's pseudo anonymous. But now in Midnight, you're going to be able to prove that you are compliant based on certain things. For example, you're from the United States, let's say. So the contract just going to let you operate on those smart contracts if you send that proof, letting know the contract, okay, you're from the United States, without you showing any information at all. So anybody on chain knows anything about you, but still you're going to be allowed to operate on that smart contract.
So now, why does a ledger come into play here? Because from what I'm hearing, you don't need a ledger. You're just sending proofs to the end application, and they're just reading the proof. It's all done. You don't need any state being stored.
Yeah.
Right? So where does that come in?
Yeah. What happened? Midnight, we used two kind of technology. One it's CSwap, and the other one it's Kashina. And what happens? CSwap, it's the mechanism to let you swap tokens privately from one user to another. So if you want just to send tokens from point to point, you don't need a ledger, right? And Kashina, it's what connects the private information to the public. So if your application actually needs something to be public, you can actually connect tokens and ledger state. And everything with private. And something nice about CSwap is not just about privacy. It's about selective disclosure. So you actually can operate privately, but if an auditor wants to see a transaction, you can actually give him permission to see that transaction specifically and not anybody else.
And how do you give somebody permission to read a transaction on the Midnight blockchain?
Okay, so what happened? The addresses in Midnight is divided in a coin public key that allows you to spend tokens and an encryption. So your data is encrypted, and sharing that encryption key or proof is going to allow others to see your transactions if you allow to do that.
Okay. Okay. And then transactions on Midnight are UTXO. Is a UTXO? Is it a UTXO?
It works kind of at UTXO, but it's not UTXO. It uses Merkle trees because everything it's a commit, right? Since it's encrypted, right? But at the end, it's deterministic, and it can be thought as a UTXO, as inputs and outputs.
Okay, so it's all inputs and outputs. Okay, cool. And then every transaction has. So and then do you when you need to permission somebody to read a transaction, say I made a transaction, I want to give you the right to read the transaction.
Yeah.
Do I have to create a transaction to like add your
okay, yeah, that feature is not still available it's a work in progress. So the actual implementation, we're gonna have to wait to see how that's done, right? But yeah, it's gonna be implemented.
Because I mean, I hear, like, I'm not a Monero expert, but what I hear here is kind of, it was like based off of Monero? Is that kind of what's going on here, or is it just completely different system?
Yeah, for example, Monero uses another tech stack, but you can send tokens privately, which is the native token, right? In CSwap, you're gonna be able to create tokens, so you're gonna have native tokens as in Cardano, and be able to swap them privately, and you have this selective disclosure that you're gonna be able just not to make everything private, but you're actually gonna be able to disclose information if you allow it.
Okay, but that functionality hasn't been built yet. That,
no, that one hasn't been built yet. But what you can actually do, it's kind of composable transactions. So it's kind of like in Cardano, you create transactions and then you can compose different transactions and kind of embed it. And this is something that, for example, Edda Labs, it's building for creating a private DEX, right? A private DEX that you just have inputs and outputs, and they just put them together and make the transaction.
Nice. That's cool. Yeah, that sounds really useful. Sounds really, really useful.
Yeah.
So yeah. I when I heard about Midnight, I was really really intrigued. I'm happy what you guys are doing.
Leif, and your questions are totally nice to have, because there's actually I can see that you really want to understand how everything works. So it's
we do,
yeah,
do.
And
I think I run a small development services company, and I think I really do think that if there was a day where you had those selective disclosure of information, of on-chain information, like, I think that'd be very useful, right? I think a lot of people would want that. I think a lot of enterprises would be very interested in onboarding. I'd be,
a huge topic is going to be real world assets, right? Tokenization of things. And now with Midnight actually let you do a lot of things, right? But
I think, like, tokenizations of, like, securities and stuff. I mean, I don't want that, and nobody wants that being on Cardano mainnet, right? Nobody wants their So that's that's cool. That's cool. Nice.
Perfect, Leif. Thank you, Leif. Thank you, Atosi, and I hope to see you next session. And if you know anybody that wants to learn Midnight, just share this documentation. We're gonna make all this material available on YouTube as well.
Sounds good. Do you have? Is there like a I know development's too chaotic, right? There's too many unknowns, right? But is there like a target date for, I guess, like a mainnet release? Is that
No, there is no information yet available, but based on what Charles are mentioning, they're pushing really hard to be ready this year, right? But there's not been any public announcements yet.
And are you like on the development team? Are you dev relations? Or are you?
No, I'm part of the Mesh and Edda Labs teams, and these both companies, they have partnerships with Midnight.
Oh, okay, cool. Nice.
Okay, Leif, Tosi, thank you very much, and see you next session.
Yeah, bye.
See ya. Bye.
Bye.